Today, let us explore semiconductor yield, a critical metric determining the efficiency and profitability of semiconductor production. Semiconductor yield is the percentage of functional chips on a wafer after manufacturing, and achieving a high yield directly correlates with reduced costs and enhanced production efficiency. Let us examine how each stage of semiconductor manufacturing influences the final yield. The yield journey begins in the design phase, where engineers use advanced computational tools to create detailed semiconductor models. Design for manufacturability, DFM, principles are applied to minimize potential yield detractors. A robust design is the first line of defense against yield loss. Testing is integral to yield optimization, starting with simulation-based testing. Engineers use models to predict device behavior under various conditions, identifying potential flaws before physical prototyping. Bench testing follows, where individual chips are evaluated under controlled conditions to verify they meet fundamental design specifications. Power consumption, signal integrity, and operational frequency are measured and compared against design goals. Early identification and correction of discrepancies here set the stage for higher yields downstream. Application testing subjects chips to their intended environments. System-level testing integrates the chip with other hardware and software, ensuring compatibility and identifying integration issues like electrical interference and data throughput limitations. In the assembly and packaging phase, the semiconductor die is encapsulated in a protective casing involving die bonding and wire bonding. Testing for mechanical, thermal, and chemical resilience ensures the chip's robustness, directly influencing yield concerning product longevity and reliability. Automatic test equipment, AT, rigorously tests chips under simulated real-world conditions, validating quality and durability and minimizing late-stage production failures. Quality control is continuous, encompassing inspections and measurements throughout the manufacturing cycle. Statistical process control, SPC, techniques monitor production processes, maintaining high yield rates across batches. Reliability testing focuses on long-term performance, with tests like accelerated life testing predicting chip life expectancy by identifying potential failures. Yield is a critical financial metric in semiconductor manufacturing. Higher yield means more functional chips per wafer, lowering production costs and increasing profitability. The future of yield optimization lies in emerging technologies like machine learning for predictive maintenance, advanced metrology techniques, and next-generation lithography. Continuous optimization and adaptation to new technologies are crucial to staying ahead in the semiconductor industry. Every step, from design to final testing, ensures the tallest possible yield.